Now, in the last session, we were trying to see an overview of an introduction to the Maven tool. And in that, I was just telling you what is exactly is Maven and what is its advantage. And to jump on further, first let's understand what is the architecture of Maven. Okay. So now, what exactly is Maven? Maven is a build tool. So if you take a build tool, now, any kind of build tool that you take basically will require something called as a configuration file. Okay, so a configuration file is nothing but a specific file for a project through which you will be able to tell that build tool on what to do. So that if you have a project based on Java, now what exactly you have to do, how the project is defined, all those details will be specific to that file only. So like this, for every project, you will be having a specific configuration file through which you will be defining the details about that project to Maven. No matter Maven, any other tool that you take specifically on the build side, it will be having a configuration file related to project. So like this, for each project, you will be having one configuration file. In the same way, now in Maven also, for a particular project on which you are going to work, you will be having a configuration file. And that configuration file, which will be specific for a project, is what we call it as pom.xml, where it is a XML file and the name of the file is POM. So we'll talk about in details on what the contents of it. As of now, you just have to know that there is a configuration file called pom.xml in which we will be giving all the details about the project. So assume that you have a project in which you will be creating a specific file called pom.xml, which will have all the details about your project. And it is the same workspace in which you will be having all the source files related to that project. So let us assume that way. So basically, these pom.xml will have all the details about your project in terms of where is the file, what and all are the details you have in it. And in it, whatever the goals that you're going to specify to the project will be basically available. Once again, in the last session, if you remember, I said anything that you're going to specify to Maven will be through something called as goals, where this goals will invoke a plugins, and this plugins will actually call a task. So how exactly does Maven know what is it has to do for a particular project is what we will be giving it in the configuration file. So basically in the configuration, you will be defining what are the goals that you need to work on so that when you call Maven for that project, it will try to read a file called pom.xml, which is available in the current directory of your execution. So whenever you are trying to call Maven, you will go inside a workspace in which you will be having a specific configuration file called pom.xml, and it will try to read the details about that pom.xml, and based on that, whatever goals that you have specified, it will try to run. Okay, so the first thing that Maven does when you try to execute is it will search for a file called pom.xml, which is the configuration file available in the same directory from where you are invoking Maven. So it is always a practice that we should be having pom.xml under your project workspace or a directory where you have all the source code of your project. And when you invoke Maven, it will try to search for this file called pom.xml in the same directory. And when you invoke it, what it will do is after searching for the pom.xml file, it will try to do the task based on what you have said. So in that, basically, it will try to take two things. First, it will take list of source on which you have to perform some operation. That is, do you want to compile the file, or do you want to delete some file, or do you want to create a package like that? What exactly you are going to do, and for that, what and all files are going to be there? It will take a list. And second, it will take a list of resources needed for this. So when you say a resource is nothing but a plugin using which it will be performing a task. Now, if I say do a compilation on your project, what and all files are there, those details, it will try to read it from the pom.xml. And from that, it will try to now do a list of tasks it has to do. So if your interest is to do a compilation that you have specified by the goal, it will have to take a list of resources that is needed for compiling these files. So that way, the second thing that it does is it will take a list of sources and resources on which it is going to perform. Basically, these resources are nothing but the plugins using which it will be doing a particular task, or it could also be some dependencies. So whatever is needed for performing a task, it will take all the list. So that way, other than the source code, whatever the resources that is needed in terms of plugins and the dependencies, where will it search? So basically, in your machine, when you're running Maven, there will be a directory called as local repository, which is nothing but a simple directory available in your machine. Now, in that directory, it will check whether those files are available. So remember, if you execute Maven, first on your current directory, it will check whether there is a file called pom.xml. From that, it will try to take a list of all the sources on which it has to do some action. And for performing an action which you have specified through the goal, it will try to take a list of resources which is needed. Resources, which is nothing but what and all are the plugins needed and what and all are the dependencies for that. So all those details other than the source will be checked in a particular file called local repository, where local repository is nothing but a directory in your machine which gets created when you run Maven. And it is the directory in which it will be checking for all the resources, that is the plugin or the dependencies. So remember, now when you run Maven for the first time, this local repository will get created and the file whatever you need will not be available. So without the sources, it cannot do anything. So that is how, if a resource is not available in this local directory called local repository, what Maven will do is it will go to the internet, and in the internet there is a location called remote repository from which it will be trying to pick the file, download it to the local repository, and from here it will be using it. So remember, for the first time when you are running Maven, whatever plugins or the resources that it needs, it will not be there in the local repository. So it will try to download it from the internet and try to put it into a folder called local repository, and from here it will be trying to use. So that is how, when you're running Maven, pretty much internet is mandatory, because for the first time it will try to download automatically all the plugins that is needed, and it will try to use it from the local repository, so that the next time when you run the same command, all the resources that is needed, if it is available in the local repository, it will pick it up. So remember this, it will take a list of sources and resources, and whatever sources is there, it will be present in the same folder, and whatever resources is needed, it will go to the local repository, check whether it is available. If it is not available, it will go to the internet, download it, and then use it. In case if it is not available in the local repository as well as in the remote repository, then it will fail. So we'll talk about those scenarios later, but otherwise it will search for all the dependencies and the libraries or plugins needed from this local repository. If it is not available, it will check on the remote repository and it will try to download it. Okay, so this is the architecture on which Maven works. So remember, whenever we are going to work on Maven, this is how it is going to be. So there will be a workspace which will be acting as your project directory, and inside that you will be having a specific configuration file called pom.xml, and inside that you will be defining what are the details that you want to tell to Maven. And when you call Maven, you will be calling Maven inside this workspace and in the same directory where you have the pom.xml, so that you call Maven by passing a goal to it. So Maven will try to read the pom.xml, and based on that, it will try to take a list of sources. And for that, whatever resources is needed, it will take a list and it will try to search whether it is available in the local repository. If it is not available, it will go to the internet, try to download it from the remote repository to the local repository, and from here it will try to use it. Okay, clear on what is the architecture, so that when you're actually trying to install Maven and run, this is what we will be doing. Clear on the architecture part? Any questions? Others? Vinay, Sayed, Kavya, Nagesh. Okay, so now moving ahead, what exactly is Maven? Maven is a build tool in which it is going to give us a set of standard. It is going to give us a defined life cycle as well as on the dependency management, right? So let us now try to understand what exactly is the defined life cycle it is going to give, and what is the set of standards that we have to follow in Maven. So with the understanding of architecture inside us, now let's moving forward. Now Maven, if you're working on it, it will try to give us a defined life cycle which we have to use for going through the build. Okay, so when you say a defined life cycle, there is an order in which it will always be executing. And the default life cycle of Maven, which we will be going through always, is this, where the very first step of what we will be doing in terms of running a Maven for a project is, first thing, to generate the sources and resources. As I said, when you execute, what and all it has to perform, it will try to take a list, and for that, what and all it is needed, it will also try to take a list. Okay, so that's the very first thing that it prepares itself. And after that, the very first thing it actually executes is compilation. So compile is a phase of Maven's lifecycle where, for your project, whatever Java files that you have, it will take a list of everything and it will try to do the compilation. Where, what do you mean by compile or compilation? For all the Java files that you actually have in your project, it is going to convert. So compile means, if you have a file called Java file, then corresponding to that Java file, it will try to create a class file, which is nothing but object file. Like this, for every Java file that you have in a project, there will be a corresponding class file created with the same name, which is going to act as a object file which a machine can understand. So going back to the basics, compilation means converting a file that is in a raw format, which is in a Java format, into a file which a machine can understand, which is an object file. So this step of converting it from a raw source code into an object format is what we call it as compilation. So that way, for each and every Java file that you have in your project, when you do a compilation step, Maven will try to convert all of them correspondingly into a class file. So that is the very first step that it is going to do in terms of compilation. So once it has done all the compilation, the next step that we are going to do is testing. So what kind of testing it is? So basically, Maven will try to do a unit test. A unit test is nothing but a particular testing that a developer is going to do, through which he will try to know whatever the code that he has written is working fine. So that way, now whenever you take a Java project, it is the responsibility of a developer to write a code that is a unit test code which is going to test the file whatever he has. So that way, for every Java file that he is going to write, there should be a corresponding test file for that. Okay, so suppose if 1.java is the actual source code, then in order to test this, he has to write another file which will be test1, which will be the default naming convention, and that will also be a Java file. Okay, so now using this test file, you are going to test this one.class, whatever it has been generated. And once again, when you want to do a test, this is also a raw file. So this should also be converted first into a equivalent class file. So this is how, when you say a unit test, what exactly this is going to do is, first, it will convert these test related Java files into corresponding class files, and then it will execute it. So while it is executing, it will be testing the corresponding class files which it is referring. So this way, now let's say there is one more file called 2.java, and for this you are going to get a 2.class when you compile, and for this also there is going to be a Java file which is the test going to refer, and when you run the test phase, it is going to compile these files which will create the class files correspondingly. Okay, so compile means first it will execute these two things, and when you say test phase, after the compile phase, it is going to run the compilation step of this, and then it is going to run this class files through which it is going to test these two files. So it is the responsibility of the developer to write all these files along with it. So it is a practice where for each of the Java code a developer writes, equivalently he has to write a test Java file also. Okay, so that is the second phase after the compilation. Now, once you have done the complete test, you will be getting a result of the unit test, whether how many tests has been covered using this test files, and whether all this test which you have taken here has been run, and what is the output, whether it is running successfully or not. All those details will be tracked, and Maven will be giving you the result of it. Okay, so once the test has been completed, the next thing what Maven will be doing is a step called package, where packaging is the assembly step, where it is going to create a deliverable for a project. So ideally now we are going to combine all these class files and create a single deliverable. Okay, so in terms of Java, what are the packages or the deliverables that we will be giving? So usually when you combine these class files, basically you will be creating an output called as jar file or var file or EAR file, where jar file is the basic format of a Java file which you will be storing all the class file into it. So when you say a project, if you are going to give a deliverable, by default the output of a project will be any one among them, where the default type of a Java deliverable will be jar file, in which jar stands for Java archive. Okay, just like how you have a tar file or a zip file, in Java, if you're trying to create a deliverable, then based on certain class files, you are going to create a jar file. Okay, so this will be the standard file. Now, what are these other two files? A var, okay, before that, what is a jar? Jar is nothing but Java archive, which is going to contain one or more class files, using which when you execute that jar, it will be calling those specific class files inside it, and you will be getting a particular functionality. So that way, jar is nothing but a combination of several class files through which you will be getting a particular functionality. Okay, that is what we call it as a jar file. And now, in some time, if you are not just running a normal Java application, but specifically a web-based application, then whatever package that you're going to create is what we call it as var, where var stands for web archive. Okay, now it is nothing different where a var file is also going to contain the same class files. In fact, it is going to contain many jar files inside it. But in addition, it will also have certain more files which is needed to define your web application. Like if you want to create a web application, you need a couple of jar files inside which it will be referring to a class. And also along with it, you might be needing some HTML files, XML files, everything together, so that if you run a var, you are actually going to run a web application. Whereas jar is a simple Java archive where you will be getting a application normally. But if you want a specific Java application, even in that, you will be having a jar or a couple of class files, and along with it, you will be having some more web related files. That is what we call it as var. Now, in some companies, if you are trying to give a var, which is a web application, if you want to give it as a licensed var file specific to that company, then you call it as a EAR. So there is no difference between again var and EAR. Other than that, EAR stands for enterprise based web archive. Okay, so a var is a generic file, a web application that you will give, but you want to give it as a specific enterprise based licensed file, then we call it as a EAR, where in addition to whatever contents you are going to have in the var, you will be having some license related files. So that's how is the difference. But pretty much by default in Maven, when you say package, what is the next thing that it is going to do is it is going to create a project jar file in which it is going to consist the combination of whatever class files that you have. Okay, so now it is not going to contain these test files because this is only for testing. What is your actual product? This is the file, so you have converted it. This is what it is going to contain inside it. Okay, so when you say package, based on whatever files that you have in your project, which is the object files, it is going to create a jar or a var or a EAR specifically based on what you have defined in your pom.xml. So based on that, it is going to create. But by default, it is going to create a jar file out of all the files that you have in your project. Okay, so understand that. Now, once you have done the package, then the next step what you have is what we call it as install. Now, what is this phase called install? Now, to understand install, you need to first understand what is the purpose of install. Now, install is a phase where, suppose if you have a dependency of one project with another project. Now, let's assume that you have two projects. Okay, so you have project A and you have project B. Now, when you compile and package A, you will get a a.jar. Okay, let's assume that. And when you compile B, you might get a b.jar. So this is separately. But if I say the project B is actually dependent on A, where the jar b.jar should contain the contents of a.jar, and if you are specifying the dependency in such a way, then when you are actually compiling or running the Maven for project B, we are specifying that b.jar requires a.jar as a dependency. So that way, now if you're doing compilation or any other step, what is the first thing Maven is going to do? It is going to generate the sources and the resources. So now one of the resource which the b.jar or the project B requires is a.jar, right? As a list of resources that it needs, it is going to need a.jar. And by default, when you run Maven for this project, Where is it going to check for the dependencies? Going back. So it is going to go to the local repository, and from here it will check whether the a.jar is available. Practically, if it is not available, it will go to the internet and it will try to search and download it there. But if you look, a.jar is not a common file which Maven is giving us. Unlike other plugins, the a.jar which you are going to use in Maven is a specific project which your company will be having. Now, that file will be available only in your laptop or in some machine where you have actually built it. It will not be available on the internet. So what will happen? The a.jar will neither be available on the remote repository nor it will be available in the local repository. So that way your build will fail. So what is that you have to do now is, wherever this a.jar is available, you have to actually copy this file into the local repository, so that when you run the project B, it searches for that a.jar in the local repository and it will be available. Okay, so that step, when you have such a kind of dependency and when you want to make a particular project's deliverable to be available in the local repository, is what we call it as install. So simply, install is nothing but, if you are running against a project, what it will do is it will take a copy of that project's output and it will copy it into the local repository. Okay, so that step is what we call it as install. So remember this once again. Install is not needed for all the projects, but if it is run, what it will do is, for whatever project you are running the install, that project's output or deliverable, it will try to copy from that location wherever you are running. So if you are running a project from that directory, it will be creating the specific output or the deliverable in the package step in the same directory. So it will copy from that directory and it will put it inside the local repository wherever is referred in the machine, so that if you run any other project which has the dependency of that particular deliverable, it will be available in the local repository. So that way, install means copying a deliverable of that project against which you are running. It will try to copy that file into the local repository so that any other projects which is dependent on it can easily refer to it from the local repository. So like this, if you have a dependency of a project, we have to make sure after creating the package, we will run the install step. Okay. Getting it? Okay. So after the install, the next step is deploy. Okay. Now what exactly it is going to do? When I say deploy, deploy means you will be having a production environment, or you want to have a particular location on which you want to start accessing this application for testing further, or to use it for using as a production system. So that is when in the deploy, you actually tell which exact location is your production location, or the location where you want to put your particular deliverables created. Because now as a DevOps concept, we are not just focusing only on creating the deliverable, but you can also verify whether these deliverable that you have created in the package step is fine for deploying. So based on your need, if it is needed, you can actually specify that location where you want to put the file. So simply, once again, deploy is nothing but taking that particular deliverable of your project, that is a jar file or a var or EAR, and put into some particular location based on what you have specified, so that your application can be accessed from that location. So that is what we simply call it as deploy. So depending on where you want to put, a deploy can be actually putting your deliverable into a production web server so that you can run it, or you can put a particular deliverable into some other storage tool in which you will be trying to store. Okay, so depending on what exactly is the environment where you want to put your deliverable and for accessing, you will be specifying the deploy step. Okay, so we will talk about more on what exactly is deploy as we go through. But for now, remember, deploy is the last step where it will be trying to put the specific deliverable, whatever that you have created, into a location where you will be able to access the application. So these are the phases of Maven, which it will be trying to go through from the beginning to the end by default. And when I say from the beginning to end, no matter if you call any of the phase, it will always come from the beginning and it will go in the same order. So let's say you are interested to create the package only. Then what it will do is it will try to come from the beginning of first generating the sources and resources, and then it is going to do the compilation, and then it is going to do the test, and then it is going to create the package and stop only at that space specific to what you have specified to the Maven to run. So if you have said to the Maven to do only package, then from the beginning, it will try to do all the steps as part of the default cycle, and then it will stop there. Suppose if you say run only the compile, then it is going to basically come from this step, do the compilation and stop. So no matter what phase of Maven you ask Maven to run, it will always come from beginning and stop only at that. Suppose if you say you want to do the install, for doing the install, you need to create a package. For creating a package, first you need to compile and test, right? So basically it is going to come from in the same order from the beginning, and then it is going to stop at that particular phase. So you have to choose on what is the phase you want to run, but when you choose a phase, it is always going to come from the beginning and it is going to stop at that place, but it is going to go through the same order. Okay, yeah. So testing is basically doing a unit testing, whereas compilation is the actual step in which you will be converting the raw source code of your project into the class files. Whereas the compilation error can happen anywhere. It can happen during your compile phase or while compiling your test file, because that is what I said, right? When you run a test, you are actually doing two steps. First thing is you are compiling the test related files and converting into a class, and then you are running this actual class files to test the class files of your project. So that is how it, with respect to what step you are running, if you get an error over there, it will stop it. Okay, so testing means in Maven, you are not just running the test, but you are first doing a compilation of the test file itself and then do the testing. Whereas the step before that, which is actually going to do only the compilation. But what compilation? Compilation of only the source code of that project, not all the other test code. Only the source code related to the project, it will be trying to compile. Getting it? We'll talk about deeper and we'll try to see the project, how it works. But first, I want you guys to have an understanding on what exactly it is doing. Okay, so remember this. Now, along with the default lifecycle, now there are certain other phases of the Maven. Okay, now what is that? So there are other phases. Now here, the difference between these phases of Maven and the one above that you see is, the difference is these are not default lifecycle. When I say default lifecycle, whatever that you call, it is going to come from the beginning and stop at that. Whereas if you call these phases of Maven, it is not dependent of any one of them. That is why these are not called as default lifecycle. Only these are called as default phases of lifecycle. So that way, if you are invoking any one of this, it will be doing a particular activity related to that itself. It will never call any one of them. For example, as I said, if you call package, it is going to come from the beginning and stop. Whereas if you call this clean or site, it is not going to do anything from here. It is going to run only that. Okay, that is why we call it as non-default. And what exactly it is going to do? So if you call a phase called clean, then a clean is basically going to delete all the runtime files that you have created in your project. So what do you mean by runtime files? So by running Maven, whatever files that you have created, it is basically going to delete only that. Okay. So when I say runtime files, now if you look, runtime files are nothing but these class files, this jar or var that you're creating. And while you're running the test, you might be getting some kind of test results in the format of XML files or text files. So those things along with this is what it is going to clean. So that when you are trying to create a product, if you do not want to have any previous reference of the changes that you have created first, it is going to basically remove everything. So clean means it is not going to delete these source code, but whatever the runtime files that you have created, it is going to delete those files. Okay, so clean means it will delete all the runtime files and it will not do anything else. And same way, site is another independent phase which will help us to create documentation of our project. So site will try to take a complete details about how the project is created, what and all details do we have in the project, and then what dependencies do you have in the project. So that way it will be easy for a developer to refer to what is the content of your project through this site, which we will also see it later. Okay, so now understand these two are the phases of Maven. And not only this, in fact, when I told some time back that when you want to call Maven, you will be calling a goal or passing a goal to Maven, right? So these are the default goals which you will be calling to Maven. So this is how when you invoke Maven, you will be giving these names that you are seeing as it is. So these are nothing but internally goals to Maven. So now if you want to do only compile, you will say Maven compile. If you want to do package, you will say Maven package, wherein it will go through all the steps from the beginning. If you want to delete all the runtime files, you will say Maven clean. So these things are not just acting as the lifecycle phases, but these are going to be your default lifecycle phases, and these are going to be the goal which you specify to Maven, through which Maven will take care of creating a project or running the project which you are interested to take care of through Maven. Okay, so remember these are the default goals as well as the phases of the Maven lifecycle. So now when you are trying to invoke, basically the executable for Maven is called as MVN. So if you install Maven on your machine, you will be getting a file called MVN, which is the executable. So when you are calling it, you will be passing a goal to it. So against a project which you are running, you will be giving the goal. So based on the goal that you have given, Maven will try to execute all the phases that it has been attached to. So that is how, if you say Maven install, you are telling the Maven your goal that it has to run for whatever project in which you are invoking this command is the install step or phase. So for install, we know that now it is going to begin from generating the source and resources, and then it is going to compile, and then it is going to do a testing of that files, and then create a package. And after creating a package, it is going to do the install. Same way, if you say Maven clean, it is just going to do only the clean and nothing else. Now, if you want to pass more than one goal, like passing it as clean space compile, now you are saying two goals to the Maven. So what Maven will do is, Maven will first do it in the same order where first it will execute clean. And when it is executing clean, we now know that there is nothing it has to do specifically. Correct? So for clean, it will actually delete it. And then after completing the clean, you have specified one more phase or the goal called compile. And for this, what it has to do, it has to basically do a compilation. And before that, in the compilation, we know the order is first it will generate and then come to compile. So like that, based on the goals that you have given and based on the life cycle phases, it is going to execute it one by one. Now, if you look at this particular phase, now I have given two goals, that is compile and install. Now what will happen? Maven will execute one by one. So first it will try to execute compile. When it is trying to execute compile, what are the first steps it will do? First it will generate the sources and resources, and after that it will try to do the compilation. That is the next step that it is going to do. Now, after that, it is going to run the next goal called install. And when you're running install, once again, what does it has to do? It has to come from the beginning where it has to generate the resource compile. But Maven is smart enough not to do the duplication work again, because when you say install, it is actually going to do the compile as part of it, right? So when I say install, it is actually going to come through compile. In the same way, if I first execute compile and then if I running install, for install, since the compile is dependent and you have already executed it, it is not going to run this once again. So it is going to continue from the compile by skipping the compile phase. Okay, so that's how, if you give these two phases together as a goal, then it is not going to run it two times. Basically, both of them is equivalent to just saying Maven install. Okay, so that's how Maven is smart enough to understand and take care of your project. Okay, and further, now if you say something like this, so first it is going to execute the test phase, and for that it will come from the generating sources and resources, compiling, and then it will do the test. And after that, it will try to call the next goal clean, where it will perform the clean specifically and it will not do anything else after it. Getting it? On how you're going to invoke Maven, what is the goal you will be passing, and what is the life cycle in which Maven will be trying to go through. All right, fine. Now, quickly, let's look into the next one. So now I said Maven is actually a project management tool where it is actually going to give us a defined lifecycle, and it is also going to give us a directory structure or a standard. So if you remember, I said Maven is going to give us a standard, right? There is a particular standard which we are going to follow. So what exactly is that standard we are going to follow? So the standard that we are going to follow is actually a directory structure. A directory structure is nothing but a folder, and whatever contents you are going to put, you're going to put it in a specific way in Maven. So what is that standard directory structure? So now, if you're working on Maven, the first thing that you have to do is, on a workspace in which you are having the files for a project, you have to create a folder called src. Okay, now to explain it, now let's say you are working on a directory. Okay, this is a directory or a workspace. Now assume that way. Now if this workspace is going to be acting as your project workspace, and if you want Maven to work on this, the first thing that you have to do is you have to create a folder called src. Okay, now in the same directory, you are going to put the file called pom.xml, which is the configuration file also. So this is the first standard structure that we have to create. That is, for any project workspace or a project directory, it should be having these two things. First, a pom.xml, which will contain all the details about what and all are your files and what you have to do. And next, it will have the folder called src. Now,
under the src, you will be having further two folders, that is src main and src test. That is, inside the src, you will be having src main and src test, which is under the src. So to be specific, let me put it up here. So like this, you are going to have further two folders under main, under src. Why do you need these two folders? Now, if you look into the Maven, I was talking about the actual source code which you are going to use as a project. So these are the actual files, and along with it, you also have some test related Java files which is used for doing the testing, right? So that way, now all the actual files which is going to be considered as your project will be put under main, and all the files which you are using it for testing purpose will be going under src test folder. So remember this, you will be having two folders, that is src main and test, where main will contain all the actual files which will be treated for your project deliverable, whereas all the files that you're going to use it for testing, the file under main will be put under test. Okay, now further inside it, you are not going to dump everything directly. Now, under the main or test, you are going to have certain other directories specific to what kind of files you are putting. Suppose if you are interested to put all the Java files, then further inside the main, you will be having specific folder called Java, and in this, you will be putting this 1.java, 2.java. Okay, so inside that, you will be actually having the 1.java, or you will be having the 2.java. Same way, even under the src test, you will be having a Java folder, and in that you will be having all the test related file for these source code. So you will have the 1.test 1.java, and then correspondingly you will have test2.java. Okay, so like this, you will be having a specific Java folder under main and under test, which will be having all the Java files for this as well as this. And now, depending on what kind of project you are working, there might be certain other folders inside it, just similar like Java, that is resources or filters or assembly or script. So same way, even in the test, you will be having certain files specific to some kind of file supporting your project file. So if the Java project needs some specific libraries supporting your Java, then you should be creating a folder called resources, and you should put everything under it. The same way, for any test Java code that you have, and for supporting it, you need any libraries or resources that is needed, then that you will specify it specifically under a resources folder in the test. Okay, and further, let's say if you are creating a web application, not just a normal Java product, but a web product or a web application, then you will be requiring certain other folders like assembly or configuration, where you will be putting all the web related files into it. So a developer or a user who is going to create a project will basically have to create all these folders and put the files exactly in this structure. So that is how, no matter what Maven project you open, you will always be having this structure. First thing that you will see inside a Maven project is you will be having a pom.xml, as well as you will be having a specific source directory. And inside that, you will be seeing a main folder and a test. And further inside each of them, you will be having Java or resources or the other specific files in which you are going to put the specific resources, or simply under the main Java or test Java, you're going to put all the files for your project, where main Java will have the actual source code for your project, and the test Java will have test related files which you are going to test the files which is being present under main Java. Okay, so this is the directory structure that we are going to use. Now, going back to the first module that we have used. So now when we are creating a workspace or a repository for a user, we are not just going to create an empty repository. So if a person is going to use that for creating a Maven project, now while creating the repository, you will be creating this directory structure and give the user, so that when a developer now he's trying to do some change, he's not going to do the change directly in the repository or in the workspace, but he's going to create the structure, and inside the structure he's going to store all the files. So the advantage here now is, whenever I create a workspace, I will have the files as well as we will have the directory structure which is needed for the Maven, so that we can use it to run any point of time. So that is how you will be actually seeing your project in your Git repository that is needed for the developer will be in the same format. Okay, so now remember that that is how a developer will actually use the standard structure and do the modifications of all the files. So he'll not be just doing everything directly, but they will be trying to use this structure and work by putting the files inside it. And where is that they are going to store? Anything now they store will be a Git workspace internally on which you are going to work. And if you need the files, you're going to create a clone of your Git and get all the files. So that is how Git is related to the build also. So now either a developer has to do some testing or build, or we are creating a product for giving it to the QA for testing. When we create a workspace from the Git, we are going to get the complete directory structure which will have all the files needed, as well as the directory structure which Maven is needed. Okay, so that way you are going to follow the Maven's standard by having the same directory structure as well as the form.xml, whatever is needed, which will be checked in into the specific repository. So coming back, this is what as a standard that we are going to follow. That is, you're going to have this directory structure and the files inside it, as well as the pom.xml. Okay. And since we have spoken about what is the directory structure or the standard, and what is the life cycle of Maven as well as the architecture, let's just give an overview of what is this pom.xml. Let's not get deep diving into it, but let's try to understand first on what is the pom.xml. So before coming into it, now, if you remember, I said to run a Maven, it needs certain resources, as well as you need certain dependencies. So if you are working on Maven, how exactly it is going to identify each and every project, each and every plugin or dependencies, whatever it is needed, because now everything is related to Java. So ideally, whatever plugins that you are going to use, right, internally, these are also nothing but some jar files only. Okay, so when you say plugins, dependencies, or resources, these are nothing but jar files which Maven itself is giving to you. So that way, how exactly Maven is going to uniquely identify every project? Okay, now Maven uses something called as coordinators. So let's forget about Maven for a minute. Now, do you understand by the word called coordinators? Or in your day-to-day life, have you ever heard of a word called coordinates? Anywhere. Like you might be watching in a movie or when you studied. Have you ever came through a word called coordinates? It's not the coordination, but I'm talking about coordinates. Have you ever referred to it anywhere that you can recall? No? Have you ever seen a graph sheet? So in a graph sheet, you have something called as x-axis and y-axis, right? What is that? You call them as coordinates. You take a map. In a map, you have something like longitude and latitude. What is that? It is a coordinate, right? What is the purpose of a coordinate there? Anyone? What kind of information you're passing? Yeah. So you are trying to identify something specifically, right? So if you have a map and you want to refer to a particular location, you will use the longitude and the latitude and refer it. In the same thing, if you have a graph sheet and you want to specifically go to a particular location, you will use the coordinates to refer to it. In fact, if you open your Excel sheet, you will be having rows and columns. How is that you are going to specifically use it? For example, let me show this. So now, how are you going to tell to the graph or pretty much in the Excel sheet that you want to come to this location? So you're going to say it is the third row and second column. So you will say in the column B, go to third row. So that is how coordinates are nothing but specific location or reference to something of your interest. Correct? In the same way, now in Maven, if you want to identify a project or pretty much a dependency or a plugin, you are going to use something similar in the terms of coordinates. So what are the coordinates that you are going to use in Maven? So the coordinates that you are going to use are referred as GAV, where GAV is a combination of three separate values put together. It acts as a unique identification or a coordinator for referring to a project. Okay, so if you look, the G stands for a string or a word which represents the group of your project. So basically, G will be pointing as a string or a name that you will be giving to identify your company. So basically, G means it will be giving the name of your project group of your company on which you are trying to do some task. Okay, so it is simply a name or a string which is going to represent the group or your company name. Then A stands for artifact ID, where artifact as ID is nothing but the name that you are going to give for your project to handle. Okay, so whatever name that you're giving for your Maven project, that is what you refer it as artifact ID. Okay, and then finally, V stands for version. So what do you mean by version? So in terms of software, if you want to identify a product, you will be not just identifying by the name, but there might be many changes that has been done to the product and we might have been released it separately or many times, right? So every time you release the product, you will be giving a unique number to it using which you will be identifying it. So same way now here in Maven, for every project, you will be using a unique version, which is once again internally a combination of three numbers, or sometimes it also be four numbers, where the three numbers that you're going to use is called as the version of the release of that particular project. And in that, if you look, for example, now if you say Windows, you're going to say Windows 10 or Windows 10.0, or if you are using any other mobile application or any other product, pretty much any software product, if you go and see, there will always be a version in it, and that will be in the format of three numbers. So you will have something like this, where the first one that you are trying to see, that is the first number before the dot, represents the major release of the project. The second number represents the minor release number, and the third one represents what is the maintenance that you have done. That means now, first you have released the product as a big version, and for that, if you have given any small releases, the number will be incremented here. And then in case if you have done any patch, you will be using it. So that's how, using these numbers, you will be giving different releases. Okay, so basically a combination of these three numbers is what you're going to use to represent a release. So now this number keeps increasing based on what kind of release that you're going to do in the company. And basically there will be someone called as release managers, or the program managers who are taking care of the product will decide on what release number or the version number that you're going to use. Suppose, let's say you are going to create a new release, but that is a major release where you have modified many things. Then for identification, they will create it like this. But after some time, let's say once you have given the product, they have to do some small fixes, and they have to give some additional functionality, but only in some small content. Then those kind of releases will be given by the name 2.1 or 2.2 as it keeps going on. But if there is some problem that they are trying to fix on this major release which they have already given it to the customer, then they will try to release it using some version number. Further, it could be like this, or it could be like this, where it could keep on increasing based on how many times they are going to give the release. All right, so these are the version numbers which you will be using to identify a release, and particularly this version ID is going to refer to that string or the number which you have used to represent. So now the syntax for the GAV in Maven is, or how Maven is going to identify any project that you're going to work, is a combination of all these three values which is being separated by colon. So that is how, now let's say you are working on a project where the name of the project or the company on which you are working, let's say I'm working for my company, and I'll call the name of my company as this. So the next thing is the name of the project that I'm going to work on is demo. So this is my group ID, this is my artifact ID, and this is the release version of the product. So if you say the GAV of this, how Maven is going to refer is, Maven is going to refer in this way. So now this is a unique ID with the combination of all the three values, which acts as the coordinates which Maven will use to identify a project. Okay, so this is how for every project we will be using a unique three values, and a combination of these three will once again be a unique value to identify a project, which we call it as GAV. And where exactly will this be? So specifically inside your pom.xml, you will be having all these details using which we will be able to track, and Maven will also be trying to understand it. Okay, so every pom.xml will have these details using which Maven will identify what is your project, or it will decide on what is the deliverable that it has to create. So as we keep running Maven, you can see you will be referring many things like this, because whatever resources that Maven is going to use internally, that will also have the same coordinates in terms of what file it is going to use. So that is how it clearly knows for this goal what plugin it has to call. So how it is going to call, using the GAV of it. And in fact, later on when we are working on Maven, where instead of the default plugin, if you want to call some other plugin of our interest, then we are going to tell to the Maven to use a particular plugin by specifying the GAV only. So only using this GAV, a Maven can understand a project or a plugin or a dependency. Anything it is going to refer this string or the name itself. Clear with it so far? Okay. Finally, now let's move on into setting up Maven. So the first thing that you need to know is, now there is no installer specifically for Maven, but Maven comes as a distribution, because Maven is an open source tool. So you can just simply download a zip file or a tar file which Maven is going to give based on the operating system, and you just extract it to a location. Okay, so that is the only thing that you're going to do. So now if you go to the Maven site or Maven download directly, so basically you will be having two types of formats that you can download, where since Maven is open source, now we can actually try to download only the binary, or if needed we can also download the source code of the Maven itself, in case if you want to do some advanced task where you want to modify the behavior of Maven itself, then you can download the source and do. But that is pretty much out of the scope of what we are interested. We are trying to run Maven, we are not interested to change anything from the Maven itself. Okay, so that way it is always that we will be downloading only the binary files, because I just want to run Maven to get some project built. So that way, depending on what kind of platform or the machine on which you are going to run Maven, you have to download this. So if you're working on a Windows machine, then download Maven zip file. If it is a Linux machine or a Mac, then try to download using the tar file. Okay, so the only thing that you have to do is now try to download this and extract it to some directory. That's it, nothing else. Okay, so download this and extract it to some location. Now, after you have downloaded and extracted to some location, now there are a couple of things that you need to know. The first thing that you have to do is you need to make sure you have Java installed on your machine. So minimum, you should have a Java 1.7 version or greater installed on your machine for running Maven, because Maven runs on top of Java only. So you need to have Java installed. So now, if you have installed Java in your machine, you will be getting something called as an environment variable. Once again, for those who doesn't know environment, basically please go through the Linux fundamentals that I have shared as a video. So that will have the details where environment variables are nothing but a variable in which you are going to store some value, and whenever you want, when you are running some commands on the operating system, it will try to pick the value from that environment variable. So basically you are going to store some value and pick it up. In that way, now whether it is a Windows or it is a Linux machine, if you have installed Java, you will be getting a environment variable called Java. Now in Windows, if you want to retrieve a value from an environment variable, then you will say percentage, the name of the environment variable percentage. So that will give you the location, what you have installed Java, or the value that you have stored in this environment variable. So this way, now first run java-version and ensure Java is installed, as well as you have the environment variable called Java home. So right now I have Java 1.8 as well as the Java environment variable set. The next thing, now after Java, you have to set an environment variable called M2 home. Okay, so once again, if you quickly want to know how is that you're going to set up an environment variable, now go to your machine, right click, properties, and in the properties, go to advanced settings on your left hand side. And in this, if you click, you will get a box in which you go to environment variables. And in the environment variable, you will be getting a box like this. And in this, what you have to do is you have to click new, and whatever the environment variable that you are going to create, you have to put. So in our example, I want to create Java home and I'll put it here. Or if I want to create M2 home, I'll put it here. And whatever value that you want to put, you will be putting it here. So like this, you can see that I have created all the environment variables that is needed for me. So remember, you're going to click on this new. Don't use this. If you don't know exactly about your operating system, then use only the first half and try to use this only. Okay, so click this, create a new variable name, whatever you want, and in that, whatever specific value that you want to put, you will be putting it here. Okay, now the same thing, if you are trying to use a Linux operating system, then you are going to use some commands like this, where you will be saying export and the name of the environment variable. In my case, I will say M2 home and equal to whatever value that you're going to give, you are going to enter it like this. Okay, so this is how you will be setting an environment variable in Linux. And Windows, you will be going to the system properties, environment variable, and create a new one. So what is the value that you're going to put in a environment variable called m2 home? So basically, if you now look, I have put an environment variable called m2 home. So m2 home is nothing but the directory where you have extracted the content of your Maven specific file which you downloaded. So if you look, this is the directory which I have got by extracting this particular file. So basically I'm using a Windows machine. So I downloaded this zip file, and if I extracted it to some directory, this is the directory where I have extracted it. So m2 home refers to the directory in which you have extracted the contents of your Maven's zip file or the tar file. Okay, so remember, this is the directory that you are going to put as a value for your Maven's installation, that is m2 home. M2 home means the location where you have installed Maven, which is nothing but the directory where you have extracted the contents of Maven. So when you extract, you will be getting some contents in this way, that is the bin folder, lib folder, and all those things. Okay, so this directory is what you are going to give as a name to m2 home. So that I have given it already. Now, along with it, there is one more environment variable called m2. Okay, so what is m2? M2 is another environment variable where you are going to give the directory called bin under your m2 home. So m2 refers to a value under your home directory, that is a bin directory. So now if you see, this is nothing but a bin folder under your home directory, right? So wherever you have extracted the Maven, inside it, you will see a bin folder, right? So you give this path as m2. Simply, m2 is nothing but under your Maven's home directory, that is m2 home. Inside this, you will be having a bin folder. That path is what you are going to give it as the m2 environment variable. Okay, this is the place where you have extracted, and inside it, you will have a bin folder, and that is what you will be giving as a value to m2 environment variable. Okay, so once you have done these two, pretty much it is good enough. But additionally, you will also have to do something called as a path variable setting. Once again, if you don't understand path, please go through the Linux fundamentals to get a deeper understanding. But pretty much to explain now, when you run some tool in operating system, now if you see here, I just ran a command called Java and whatever option to it. Now, where is Java installed? How did it know that there is a application or there is an executable called Java available in this machine and it is trying to pick it up, right? So that is because you have an environment variable called path, in which basically we will be having the list of directories where if you run a command or an executable, and if this executable is found in any one of the directory that you have given here, then basically the operating system will pick and run. So that is how, if you say Java, actually I have given the directory of where Java is available in the machine. Okay, so that is how it is able to pick it up. In the same way, now if you want to call Maven, the executable for Maven is this mvn, which is available under the bin folder where you have extracted the contents of Maven. So now we have to give this path to the path environment variable. So that is what we have to do is, in your path environment variable, you try to add this directory under which you have the Maven executable. That is, this is actually the m2 variable that we have created, right? So the content of the m2 should be added to the path environment variable. So that is how when you run Maven from anywhere, the operating system will try to search and it will try to find the directory that you have given. So because of this, it will be able to invoke the command. So if you have not added it here, it will not be knowing where to search for that executable, and that is when it will be giving some command like it doesn't know that where to run this command. So that is why we need to add the path variable, and we need to give the directory where the Maven executable is available, which is nothing but it is available in this. So here, if you set the environment variable by adding the value of the path where you have the bin location, you separate it by semicolon or a colon depending on your operating system, Maven will be understanding, or the operating system will know where exactly is Maven. So now if you see, to this path variable, I have added one more value. So the Maven is available under this location, this one, this path, I have added it. So now if I basically run Maven, what operating system will do is it will search in all the directories separated by semicolon, and if it is available in any one of this directory, it will pick it up. And I have given that in one of the directory here. So the operating system will know that, okay, Maven is available in this location. So let me call it from wherever you are running it, and it is going to execute. So you can see right now I am using the 3.3.9 version and Java 1.8. Okay, so this is how, if you get this output, it means that you have extracted Maven properly, and you have set all this environment properly, and you also have set the Java properly. Okay, so make sure you get this output, and if you get, you have set up the Maven, simply correct it. Okay, so it's all about extracting the content and specifying the environment variable properly. Okay, clear on this first thing on what you have to set for creating a Maven environment on your machine? Vinay, Hari. All right, fine. So now, once we have set everything, let's start creating a project and work. But when you go to a company, there will be already a project available. But now, for us to begin a project from the scratch, what is that I need? Now, we have to go back to this, where if I'm creating a project, first I have to create a pom.xml, and then corresponding to it, I need to create a standard directory structure, right? So rather than doing all those things, in Maven, we can again simplify the method where we can create a dummy project or a temporary project for practicing. And if needed, you can use the same thing for your production also. The only difference is you just replace the dummy files which Maven is going to give us for practicing with the actual files, because it is also going to have the same directory structure on the pom.xml. So only the contents will be varying. So that way, now you can use a command called Maven archetype generate, where this is again a goal which you are passing to Maven. And against it, it is going to call a plugin through which it is going to create a template for us which we can use to practice. And that template will have a standard pom.xml, and it will also have a standard directory structure and some dummy or sample files which we can use for practicing. Okay, so now what I'm going to do is, in my machine, I have practically created one folder. Okay, so I have actually created a folder like this, C Vesva Maven, where all the Maven related projects I'm going to store. Just like how I used the Vesva Git folder for storing everything related to Git, I'm going to create it. So it is not mandatory that you have to create it. So it is just a folder that you create in your machine where you can remember and search for the files whenever it is needed. Okay, so that way, now what I'm going to do is I'll go to that folder first. So first I'll go to that folder. Okay, and in this, if you see, there is nothing inside it. So first thing that we will do is we will run this command. So what it is going to do, Maven is going to help us by creating a template or a sample project. Okay. Okay. What exactly it did? Now, the name of the goal that I passed is nothing but archetype generate. That means you are trying to create a sample project of a specific architecture type. So it is giving you a list of architectures available in the Maven against which it will be giving the directory structure in the format what you wanted. So based on a format that you want, you can choose this, but pretty much you can alter it any point of time. So don't have to worry in case in the organization the developer will tell you what is the type of project based on which you can create a new project with this number, or any point of time you can create a standard template and from that you can change everything. So it is no difference. So now let us use the standard template of number 981. So if you just enter, it is going to pick up that. Okay, and in that there are multiple versions which Maven is giving. Again, it's not of a much interest, so just press enter and it will take the default version of this template. Okay, after this, if you note, it is basically asking us what is the group ID, that is the first value of your project. So you have to give a specific value. So let me say this is the name of the company, and then it is going to ask you the artifact ID, which is the name of our project. So I'm going to give demo as the name of the project, and then it is going to ask us what is the product version which you are trying to interested to release. Now here we are not doing any release, so as of now let's forget about giving a release number and let us use a standard name which is being used for the version. We will talk more about what it is and why we need specifically, but as of now, since we are not using any release, it is only for some kind of testing purpose, I will use a standard version which Maven gives, which is 1.0 snapshot. Okay, so if you just enter, it is going to take the same, and then what is the name of the package that you want to create. So basically now when you do a Maven package, what is the file name that you want to create is what it is asking. So once again, if you have any specific interest, you can give. If you just enter, it will take the default name whatever is available. Okay, so it is trying to cross check on the configuration and it is asking us to confirm. So if you go ahead and press yes by Y, so it is going to confirm, and what it has done now, if you look under the directory where you have run, it has actually created a folder with the name of our project what we have given. So we have given the name of our project as demo, right? So it has created, and inside it if you go, you can see it has created the directory structure whatever is needed, as well as a standard pom.xml also. So it has actually given us a complete template or a practice file or a folder for our project. Okay, so in that if you go under the SRC, you can now see you have a main folder and a test folder, and further under the main you can see there is a Java folder, and in this you are going to have a sample file. So actually it has put as a sample file called app.java under the SRC main Java. Now this is a sample or a simple sample project. That is why you do not have much complicated folder, but based on the requirement you are to just add. Is my voice audible to everyone? Hari, seems to be a problem from your side if you're not able to hear it. Sorry, is it a problem for everyone? Is it audible? Okay. Hari, can you please reconnect? Okay. So now here, as I said, it is going to give us a sample file called app.java. Okay, it is only for practicing. Now, if you go to the production, instead of the app.java, you can create any files that you want, or if you have a specific project file, you can put it inside it. So they basically, that is what you are going to do, where you can replace this app.java with any actual source code that you have for your project. But if not, for practicing, we can make use of this app.java, which has been given by the standard Maven template. Okay, next. If you further go under the test, you will once again see a Java folder, and in this, you are going to see a app test.java. Okay, so this is the test file related to our app.java. Getting it? So we had a app.java under src main Java folder, and this test app, that is app test Java, is used to test the file under the src main Java folder. Okay, so like this, for each folder that you have under the src main, you are going to equally create a test file, which is again a Java file. So now we have actually created the standard directory structure, and we have some dummy files inside it, as well as I have a pom.xml through which I'm ready to practice my Maven or to run the build for Maven. Okay, so now in order to run Maven, we have set all the configuration. So the first thing that we need to do is we need to go inside our project folder. Okay, so remember, when you're working on Maven and you're invoking Maven, as I said, you need to basically first go inside the folder in which you have the pom.xml available. So you have to run the Maven from the location where you have the pom.xml. So if you're running from any other location, then you need to specify where is the pom.xml, because by default, when you run Maven, it is going to search for the pom.xml in the same directory as where you are invoking Maven. That is why you always have to go inside the project, and from the same directory where you have the pom.xml, you have to call the Maven. Okay, so now we are inside the project. We have all the files that we need. Assume that as a developer has done some change, and now we have to run the Maven project. So in order to run, let's go through the Maven's lifecycle phase one by one. Now directly I can call package, I can call install, but let us go through one by one and see how it is going to behave. So first thing is, let us call Maven and compile. Okay, so what it is going to do, the first thing it is going to do is, it is going to take a list of sources and resources that is needed, and for that it is going to call a plugin. So how is that it is going to recognize a plugin? So for generating the sources and resources, it is going to use a plugin, and this is the GAV of that plugin. Again, we are trying to use a default plugin which Maven is giving, and this is what you see it. And using it, it is trying to generate the sources and the resources. Okay, and after that, it is coming to the compilation step, and for compiling, it is using the default compiler plugin. Again, that is being referred by a GAV that you can see here. And using it, now it is trying to compile a file. So now, since we have followed the directory structure, we don't have to tell to Maven on what file you have to pick and how many files you have to pick, because that is the advantage of using Maven, where without doing much, you can get your project built very easily. Because the same thing, if you are going to use any other tool, you have to write code in terms of specifying where your project file is, and when you say compile, how many files you have to build, all those things has to be specified. But Maven is smart enough where if you just follow the directory structure which Maven is giving, it will automatically read. That is the reason why we are following the directory structure by putting everything under src main Java. So right now it is automatically reading the structure, and it is saying that there is one file available, that is app.java, and corresponding to it, it is trying to compile it. So basically now it has compiled the app.java. So where is it going to put the output? On your project folder. Now, if you see, you would be getting a folder called target. So when Maven is running, all the output files that it is going to create will be put under the target folder, which will be inside your parent project folder only. So on the same directory where you have the src and pom, it is going to create a folder called target, and it is going to put the output inside it. So now, since it has compiled, it will be creating a folder called classes, and inside it, if you go, you can see there will be a class file corresponding to your project. Okay, so what it did now, so corresponding to this main Java that we had, it has actually compiled and put it into the target folder under classes. Okay, so compilation means converting this Java and putting it as a class file here. Okay, that is what the first thing. So now, even though if you have hundreds of file here, Maven will be trying to pick all of them, and it will try to compile one by one and put it up here. Now look at it, what happens if I run second time. When you run it once again, Maven is not going to redo everything. And Maven is smart enough to now know that it clearly says that there is nothing needed to compile. All the class files are up to date, because whatever the content that you have in the app.java, corresponding to it, it has created a file called app.class, right? So unless and until you have modified this file, you don't have to recreate it. So that is how, if a developer has not modified the file, then Maven doesn't have to rebuild it again. That is how it is smart enough to know. So first thing it checks is if there is a file already available, and if it is available and the content that you have is equivalent to that, then it is not needed to build. But in case if the file is not there, then it will create the file. But if the file is available and the content what it is there is not exactly of what you have here, that means you have modified it, so then it will go ahead and rebuild it. But this time you have the same file and there is no change in the source, so it is not going to rebuild. So that's how you are again going to save some time by running the build through Maven. Okay, so once you have completed the compile step, next let's move on to the next phase called test. So what will happen when I say test? It is basically once again going to come from generating source, compile, and then test. In this, it is not going to run the compile because we just now saw that it knows that it has already done the compile and it is going to move on to the next phase. Okay, but it is going to always come from the top, where first it will generate the resource, and then corresponding to it, it will try to compile. And in the compile, it is saying nothing to compile because we have already compiled it some time back. So after that, it is basically trying to take the test related files and it will compile them first. So that is how. So if you go to src test and Java, you have a test file which is used to test this file. So now corresponding to this, if you go to the target folder, it would have created a test classes, and inside that it will be putting a class file for this app test.java. So that is the first thing that it does when you say test. And after that, using this class file, it is going to test this particular class file. And whatever output that you are going to get, it is going to put it under a report folder. Okay, so you see here, now whatever in the app test.java it has written, and it is trying to execute based on that, and it is trying to say that these are the details that it has picked up, how many tests you have done, and what is its corresponding output. All those things it is going to put it up here. So specifically, the output will be available in this target folder. So that's how first when you run the test, it is going to compile the test related files, and then it is going to run the test basically using that output file, and it is going to generate the report. So that's how we are going to see whether it is successful or not. So in case if you have a problem anywhere, it is going to stop exactly at that location and give you the error. Okay, so once you have compiled, the next thing you're going to do is test. And after test, what is that you're going to do? Basically, you are interested to create a package or a deliverable. And the default deliverable, what we are going to use is a jar file. So now if you say Maven package, what is it going to do? Once again, it is going to come from the beginning where it will compile, test, and package. But in this now, since we have already done the step, what it is going to do is, even though it is going to come from beginning, it will just only rerun the test, whereas all the other steps have done. And after doing the test, it is going to call a plugin specifically to create a package. And since we have not specified any type of the package, the default package that it is going to use is jar type. So that is one. It is going to use a specific plugin and a GAV to identify, and it is creating a jar file. So where is it going to create the jar file? So the jar file once again will be available under the target folder, and you can see that there is a jar file available. And the name of the jar file will always be the name of your project hyphen the version that you have specified for this project. So if you recall some time back, while creating the Maven project or running the archetype generate, I gave the name of the project, that is the artifact ID, as demo, and the version is the standard. So it is going to create the output or a deliverable exactly with this name always. Okay. So to just quickly see this, now I will try to convert this into a zip file and show you what is the content, because now this jar file is going to contain all the output of your classes. So if you had 10 files, those 10 classes will be available inside this. Okay, so let me show you. So first I'll try to rename this. Let's go to the target folder. Okay, and I'll try to rename this file from demo.jar to demo.zip file. So you can see it has renamed, right? So here, let's extract it. Now you can see the content inside this. Actually, you have two folders, which is nothing but the name of your project. And inside that, you will be having a class file. Okay, so that is how, when you're trying to create a project, you're going to run it one by one. So that is how now, if you want to run the project, you will not be doing all the steps one by one. Simply, if you need the project, all you're going to do is you're basically just going to say Maven package, where depending on the steps which is not done, it is going to come from the beginning and it is going to do one by one. Okay, and finally, if the jar file is not created, it is going to create the jar file. Okay, so this is the package. So most commonly we will be using only the package. The install and the deploy are special cases that I'll be covering it little later when we go through dependencies. But for now, the most important that you need to know is how do you compile, how do you test, and how do you create a package out of it. Okay, and let's look at the other phase of the life cycle that we have, that is clean, which will be using it more commonly. So now inside this, if I say Maven clean, what it is going to do, it is going to basically delete all the class files or the jar file or any output file that I have created, which means now this target folder itself is completely going to be deleted, because this file or the folder was created as an output of running different steps, and only inside it you had all these things, right? So when you say a clean, it is going to basically delete the complete target folder itself. Okay, and again, if you see, it is calling only this plugin or no other step, whereas the other default, it used to come from the beginning, but in this it is calling only this. And now you can see you don't have the Maven output at all. So like this, you're going to clean, and whenever you want, now if you say Maven package, it is going to once again come from the beginning, where it is going to generate the source, and then it is going to generate the test related compilation step, and it is going to test and create the jar file. Okay, so basically this is what you're going to do, where you will invoke a particular phase, and based on that, Maven will be trying to behave on everything. Getting it? Are you guys getting it? Okay. So if you look now, Maven is actually smart enough because if you think what we did, the only thing that we did is we created just a folder. That is the structure that is needed, and we created a file. So by this, it automatically knew what and all it has to do, what files it has to pick up, right? So that is how, if you follow the standard structure and if you follow a pom.xml, Maven will take care of doing everything that is needed. So that way, if you try to look into the Maven's pom.xml, you can see literally it doesn't even have 10 lines, and even these lines are the standard lines which you are using. The only thing that you have in this is your GAV. So here you can see the pom is actually XML file in which whatever the GAV that you have specified, it is going to use. So with respect to this, without having any content as well as without giving any other details, the only thing that we did is we followed a standard pom.xml as well as the src folder, and using this it was able to generate the project for us. So that is the advantage, where in fact if you see less than half an hour we were able to get a project built on a Maven without putting too much of effort. The same thing if you're using any other build configuration, then you have to specify all the details on where is your source code, and for that source code what you have to do, and how many source code you have to pick up, what is the output you have to put, what is the name of the files it has to put it as an output, where it has to put, right? And what step you have to perform first, and then all those dependencies you have to specify. But using Maven, you can see it is quite easy, where we just have to follow two things: follow the standard directory structure inside which you are going to put the file, and then use the pom.xml which is going to give all the details. And that too, we don't have to give any details. By default, if you're using the default standard, then it is going to help us to work on everything. But in a production, you are not always going to work on default. So there will be some necessity where you want to tweak the process, do something additionally using it, or you want to do something more which Maven is not doing. So that is how we will be trying to add those more details into the pom.xml and tell Maven to act accordingly. So that's what we will be seeing it in the next session. Okay, so pretty much I'll stop it today. So is it clear so far on what is the standard structure, what is the Maven lifecycle, and how you're going to create a project, and with a combination of these two things, how Maven is exactly going to work using all those things. So the only thing now we have to do is, for a developer, you just have to ask him to create a structure in the same way and the file, wherein as we need, we are going to modify the pom and just call Maven with a goal, which is nothing but a lifecycle phase. Based on that, Maven, it is going to help us in creating the project.